Imaginary numbers part 2, building polynomials from imaginary roots. The fundamental theorem of algebra states that every nth degree polynomial has exactly n zeros. For example, x squared minus 6x plus 9 is a second degree polynomial, and therefore we can conclude that it has two roots, x minus 3 and x minus 3. Conjugates are formed by negating the second term of a binomial and can be used to find additional roots of a polynomial. For example, 3i plus 5 has a conjugate of 3i minus 5. This rule also applies to single-term complex numbers. 7i has a conjugate of negative 7i. Here's some practice. Pause the video and press play to check your answers. So here are the answers. Building a polynomial using given roots. Build a third-degree polynomial using the roots 2i and negative 4. We know that 2i is a complex number, and therefore it must have a conjugate, and the conjugate will be another root. Its conjugate is negative 2i. And now we'll put it in this form and prepare for FOILing. We'll start with the first two terms. X times x is x squared, x times 2i is 2ix, negative 2i times x is negative 2ix, and negative 2i times 2i is 4i squared. We'll then put these answers into a polynomial form and collect like terms. Once we're done with that, we'll get x squared minus 4, but we still have to FOIL in the x plus 4. X times x squared is x cubed, x times negative 4 is negative 4x, 4 times x squared is 4x squared, and negative 4 times 4 is negative 16. And now we'll put that into polynomial form, and there's no like terms to collect, so this is our answer. We know that this is our answer because we can check that it is a third-degree polynomial. Here's some practice. Pause the video and press play to check your answers. So 8i has a conjugate of negative 8i, and once you FOIL it together, you should get x squared, 8ix, negative 8ix, and negative 64i. And once you collect like terms, you should get x squared plus 64. So when building a polynomial using complex roots, remember, you know how many roots there should be based on the degree of the polynomial, and you can find additional imaginary roots using the conjugate rule. Thank you for watching my video, and I hope you guys learned a lot about imaginary roots and building polynomials.
Created using Powtoon.